Welcome to the lesson about smart textiles and their history. In this video, you will learn about the first time the smart textiles have been mentioned and also about their evolution up to today. The term smart textiles is derived from intelligent or smart materials. The concept smart material was, for the first time, defined in Japan in 1989. The first textile material that is in retroaction was labeled as smart textiles was silk thread having a shape memory, by analogy with the better-known shape memory alloys. The continual shrinkage of the textile industry in the Western world has raised the interest in smart textiles, which meet all the criteria of high added value technology, allowing a transformation to a competitive high-tech industry. From resource-based towards knowledge-based, from quantity to quality, from mass-produced single-use products to manufactured on-demand, multi-use and upgradable, from material and tangible to intangible and virtual, value-added products, processes and services. The discovery of shape memory materials in the 60s and intelligent polymeric gels in the 70s was, however, generally accepted as the birth of real smart materials. It was not before the late 90s that intelligent materials were introduced in textiles. First researches related to communicated textiles have been done in different laboratories in late 90s, and the first textile electronic semiconductor components have been realized in the early 2000s. Etenset, Roubaix-based French textile institute, first development in the field of smart textiles has been related to France Telecom R&D company, who expressed a need to develop communicated textiles. The idea was to build textile that will be able to display messages such as textos, etc. First optical fibers flexible displays OFFD have been developed in the late 90s. Even CNN broadcasted about them at that time. The article summarizing research results concerning an OFFD has been published in 2005 by Optical Society of America. Several generations of recently developed smart textiles are presented in this slide. The first generation, developed about 15 years ago, includes fitness-oriented underwear able just to follow basic vital signs such as heart rate. The second generation contains better integrated sensors and actuators, able also to monitor vital signs and to warn the customer. Finally, the third generation's actuators are better integrated, enabling heating of textile fabrics, and smart clothing start to be focused on medical applications such as ECG real-time monitoring for diagnostic purposes, and the setup of predictive medicine concept. This slide shows the possible evolution of smart textiles market in next years. Today's dynamic market segments such as digital, health, transportation, energy, or security have an important added value that may be captured by textiles as supports. Currently, the value of 1 kg of technical textiles is estimated to $5.3 comparing to $3.5 for non-woven textiles and $10.5 for textile composites. The smart textile market is also rapidly growing. On the other side, the market of connected objects, also called Internet of Things or Internet of Stuff, will possibly contain 30 billion devices connected in 2020. And 10% of those things will be clothes. If these figures are realistic, it means that in 2020, about 3 billion of clothes will be connected and will use some aspects of smart textiles such as sensors or actuators together with emitters, receivers and units of computation. The market share of smart textiles in that case will be even larger than statistics have forecasted. These figures are very encouraging for the textile industry globally and indicate major changes in our way of life. Social networks have introduced a completely different approach to interactions among human beings. New services such as Uber, BlaBlaCar, Airbnb, crowdfunding, etc., radically modify the economy and the cost of transportation, accommodation, etc. Several useful books edited from 2004 up to nowadays are shown in this slide. In 2004, Wearable Electronics and Photonics, edited by Professor Xiaoming Tao from Hong Kong Polytechnical University, summarized advanced projects in the field of e-textiles at that period. Hence, its student, Emmanuel Deflin, wearing OFFD, developed for France Telecom, is shown on the cover page. In August 2015, a handbook of smart textiles edited by Xiaoming Tao also has been published by Springer. It is composed of 3 sections, and Vladan Končar was third section editor. More recently, in May 2016, Elsevier published a book edited by Professor Končar on smart textiles and their applications. It contains 3 parts focused on medical, energy, and security and safety applications. Finally, in 2018, in November, a book entitled Smart Textiles for In-Situ Monitoring of Composites has been published by Elsevier, summarizing the use of smart textiles for in-situ structural health monitoring, SHM, of composite structures.